This is Mr. Komalo CS. In today's video, we are looking at electrochemistry. Today we're going to look at the electrolytic cell. So let's look at the definitions there. Electrolytic cell is a chemical cell that converts electrical energy into chemical energy. Okay? Then electrolysis is the process of breaking down compounds into their ions by using electricity. So there's a difference between electrolytic cell. That one is a cell that converts electrical energy into chemical energy. Electrolysis is the process now of breaking down compounds into their ions by electricity, which is of using a battery. Okay. So examples of compounds that we can break into their ions. We've got sodium chloride there. So if you look at this sodium chloride can be broken down into what? Into its ion, and that ion is sodium ion and chlorine ion. Again, we've got the example of water there. Water can be broken down into its ions, which can be the hydrogen and oxygen. Okay, so but for today's video, we're going to look at the breakdown of what? Of the sodium chloride. Okay, by using electricity. Right. So in actual sense, when you look at the sodium chloride is a salt, and if you look at the salt, you'll see it in its crystal form, which is something solid like that. So it shows that those small pieces which are solid like that, they are actually made up of this sodium chloride. And this sodium chloride is bonded in its ionic form, in the sense that all of these small pieces of crystal is just a combination of sodium plus and chlorine minus. Okay, so now to separate these two into their components, which is simply just going to be sodium plus as what? Plus chlorine minus. It's not that easy, but it requires the usage of what? Of electricity. That is why we are going to use the battery. The battery will act as a source of energy, providing us with electricity. Okay, so now let's look at the simple setup of an electrolytic cell. This is an example of electrolytic cell. Okay, electrolytic cell. Right, but the process that we'll be dealing with today in this electrolytic cell, that process is going to be called electrolysis, which is a process of breaking down compounds into their ions. Okay, since we said we'll be breaking down a sodium chloride to its ions. Okay, so what does it mean? It means that in this container there, you can put the crystals or small pieces of what? Of salt. And that salt is what we call sodium chloride. Right. But we know that they've combined in that type of its ionic way, by sodium is positive, chlorine is negative. Okay. So these electrodes that are here, these electrodes are called inert electrode, meaning that they don't react. They don't react. They only allow the electrons to pass through, but they don't react. They're not part of the reaction. Okay. Now, so when the electrodes are connected like this, what does that mean? It means, look at here, we have got a battery there. So a battery, we've got a positive side and a negative side. Right. So what does that mean? If you connect a battery like this, it will make this side of electrode to be positive. Okay, if you connect this this electrode on the negative side of the battery, it will make this side to be what? To be negative, meaning that the whole plate here is negative. The whole plate there is going to be what? Positive. Okay. So if it's like that, if you look at these, the geometrical bond of sodium and chlorine, you know that they are bonded like this. Sodium, which is positive, and chlorine, which is negative. So what does that mean? It means that the chlorine is, sodium is going to be attracted to the what? To the negative plate because it's positive. And chlorine is going to be attracted to the what? To the positive plate because it's negative. And when sodium gets to that point, when sodium gets to this plate, sodium is just going to stand there. Remember, it's just attracted there. And then chlorine is just going to come and stand here because it's attracted to this positive plate. Okay, but then now, because of the force of the battery, remember electrons are negatively charged. So if electrons are negatively charged, if you look at chlorine and the sodium there, chlorine is on the positive side. Since it's on the positive side of the battery, the electrons will automatically be attracted to the positive side of the battery because the battery have got a strong force of pull. Since electrons are negative, they'll be pulled by the battery out of the chlorine, and then they'll move like that all the way. And this side, when they cross the battery here, they're going to be pushed or repelled by the negative side of the battery down to what? To sodium. Okay, so that will be the movement of the electron. So now let's name our anode or cathode. So chlorine, since on the side of chlorine, electrons are going up, which is anodus. That is anode in our language of chemistry, because electrons are going up. And we know when there's anode, we've got our friend that is called what? Leo. Loss of electrons is oxidation. So you already know that this one is what? It's undergoing oxidation. If it's undergoing oxidation, you already know again that it is a what? It is a reducing agent. This side, of course, is going to be cathode or cathodas going down. Our friend there is what? Is Jerry. Gain of electrons is reduction. And that is reduction on this side. And you must know that this one will be what? Will be N. See? Oxidizing agent. So what's happening there is that on the anode, the electrons are forced by the battery to move from chlorine all the way up. Okay, they are forced by what? By the battery to move all the way up in that type of direction. It is the battery that is pulling those electrons, and then this side electrons are pushed by the force of repulsion from the battery down to what? To sodium. Okay, so what we need to understand now is this. Let's draw our half reactions. Let's do our half reactions. Our half reaction is very simple. Half reactions on the oxidation part. Oxidation, we are going to have what you call, if you look there, now we're no longer saying we're going to look at the table 4b, because this now does not follow the table 4b. What is doing this process to take place is the battery. You understand? So the element that is losing electron is the element that is on the positive side, because the battery is going to force those electrons to move out. So you can see that on the positive side you've got chlorine. So what you simply do, now you go to your 4b just to look at the formula of chlorine or the reaction of chlorine. So if you go to 4b, you can see there's chlorine right there. we've got the chlorine there. Sorry, chlorine is right there. Okay, let me see if I can write somewhere. Not willing to write. Okay, but I think we can all see chlorine is right here. So, and we say it's undergoing oxidation, so we need to write it in the reverse way. So if you write it in the reverse from your table 4b, you can look at it in your table 4b there. Therefore, what you're going to have there is going to be 2 chlorine minus in aqueous form and chlorine 2 gaseous form plus 2 electrons. Remember, I took this from the table 4b. Don't ask me why am I writing it like this. I took it from table 4b. And then on the reduction, we say it is sodium. If you look at your table 4b, you'll see that sodium will be in this type of form. Sodium ions in aqueous form plus 2 electrons. Changing to give us what? Sodium solid. Right. So now for us to write the net reaction, for us now to write the net reaction, how are we going to write the net reaction or the net ionic form? Net ionic form. Right. So our net ionic form, we need to make sure that our electrons are equal. If they're not, then we need to balance them. So if they're equal, then we can come and say this is 2 chlorine minus in aqueous form plus sodium in this aqueous form. Then it goes to give us what? Chlorine gas plus sodium gas. Okay, all right. And then from there we can go to our E cell potential. How to calculate our E cell potential? Very, very easy. Now let's calculate our E cell potential. Our E cell potential is E naught cell, which is equals to E naught reduction minus E naught cathode. Oxidation. So now look at those two elements. You see that on the reduction you've got what? We've got our sodium, and if you check the potential for sodium on the reduction, you've got sodium. Yes, if you check the potential for sodium is negative 2.71. Minus, if you check the reduction for chlorine, is positive 1.3. 6. Then you do your equal sign, you're going to get what? Negative 4.07 volts. Why is it negative? It's negative because it's what? It's a non-spontaneous reaction.